Okay, Whynauts, listos? You ready to do this?
I was born ready.
I am ready, but I definitely was not born ready. I've seen my baby picture.
Well, ready or not, there's something I want you to see.
Holy cow, look, out there. It's the Earth. La tierra.
La tierra, that's right. But now I want to show you something even more amazing. Watch this. Emma, set time landscape. Rewind 250 million years into the past. 250 millones de años al pasado.
Oh boy, here we go.
250 million years? Roger that. Engaging, timescape, rewind.
What happened to all the different continents? It's just one big one.
That's right. Roughly 250 million years ago, all the different continents were all connected into one supercontinent called Pangea.
Hace 250 millones de años, todos los continentes estaban conectados. But then, slowly, over millions of years, the continents separated.
Oh yeah, scientists were able to figure this out eventually, but it was a long process.
Yeah, those continents used to be connected, but now are hundreds and thousands of miles apart. So now let's see what some scientists think the Earth might look like millions of years into the future. Check it out!
Ahora veremos cómo algunos científicos piensan que se verá la Tierra en el futuro. Whoa, it never stops changing. No deja de cambiar.
Whoa is right. Well, now that we know what happened and what might happen in the future, it's time to figure out why.
And that's a perfect job for the Whynauts. Okay, I know you're asking why. Why did Pangea, the supercontinent, break apart into all those different continents? And why in the far distant future they're likely to come back together again?
¿Por qué el supercontinente Pangea se dividió y por qué es probable que se junten nuevamente?
Well, the answer is the theory of plate tectonics.
La respuesta es la teoría de las placas tectónicas. Nos explica por qué la superficie del planeta cambia.
The theory of plate tectonics is one of the most important theories in the history of Earth science. It explains where volcanoes and earthquakes occur and why the surface of the Earth never stops changing.
También nos ayuda a explicar dónde ocurren los terremotos y volcanes.
It may not always look like it's changing, but remember, these changes happen slowly over millions of years.
So you may be asking why, as in, why don't we explain what a tectonic plate is?
And we will, but first, let's go deep. Vayamos a la profundidad.
Profundidad? Deep? I love getting deep. What came first? The chicken or the egg? How are clowns both scary and funny? Who gets the armrest in the middle seat of an airplane? What makes...
Joey!
We're not getting deep like that. Quise decir la profundidad de la tierra.
Eso, we need to talk about what's deep beneath the surface of the Earth.
That kind of deep. That's deep.
Okay, Whynauts, let's head to the Whynauts hyperdrill.
The what?
Don't we have something we can get in, like a big drill that'll take us to the center of the Earth?
No. No necesitamos un gran taladro para ir al centro de la Tierra, but we do have the Whynauts discovery screen. Come on, gang, let's go.
Behold, the planet Earth. The Earth is divided into layers, and each layer has its own composition and unique properties.
La Tierra tiene diferentes capas. Cada capa tiene composiciones y propiedades diferentes. It's impossible to drill all the way through the Earth.
But a branch of scientists, called seismologists, have learned about the different layers of Earth by analyzing how sound waves travel throughout the planet.
Los sismólogos analizan estas capas observando cómo viajan las ondas sonoras.
There's basically 3 layers: the crust, the mantle, and the core.
Básicamente hay tres capas en la tierra.
Corteza, manto, y núcleo.
Eso, Joey.
The solid, rocky outermost layer is called the crust, or corteza in Spanish.
The continental crust,
La continental forma los continentes.
not surprisingly, makes up the continents. It's the thicker of the two types of crust.
The oceanic crust, la oceánica, is the thinner part of the crust. It lies underneath the oceans, es más delgada y está debajo del océano.
I really want to make a pizza crust joke right now, but...
But you won't! Now let's look even deeper. The middle layer of the Earth is known as the mantle. The mantle accounts for most of the Earth's interior.
La capa de en medio se llama manto y es la mayor parte del interior de la Tierra. That leaves the innermost layer, the core. It is divided into two parts, the outer core and the inner core. La capa interna, el núcleo, se divide en dos, núcleo externo e interno.
Okay, now there are two more key terms we should discuss relating to the layers of the Earth. And these are where the tectonic plates come in.
The first term is asthenosphere o astenosfera en español. Es la parte más cálida y débil del manto.
The asthenosphere is a warmer and weaker portion of the mantle.
But it's very, very viscous, which means it moves extremely slowly.
Es viscosa y se mueve muy despacio. Just above the asthenosphere is the lithosphere. Encima de la astenosfera está la litosfera. It consists of the crust and the very top part of the mantle.
The lithosphere is divided into about a dozen major different rigid pieces known as...
You guessed it, the tectonic plates.
Sí, las placas rígidas de la litosfera son las placas tectónicas. And of course, you cannot play tectonics without tectonic plates.
Imagine the crust of the Earth is one big 3D puzzle. The tectonic plates would be the puzzle pieces.
Las placas tectónicas pueden ser de corteza, oceánica o continental.
The tectonic plates can consist of both oceanic crust and continental crust, as you can see here in the South American plate.
These puzzle pieces, or plates, are rigid and basically float on top of the viscous asthenosphere. Son rígidas y flotan sobre la astenosfera.
And they move
Despacio.
That's right. The surface of the Earth is constantly changing because of this movement.
Así es, la superficie de la Tierra cambia todo el tiempo por este movimiento.
But instead of waiting around for the continents to move, let's take a brain break. When we come back, we'll talk about what happens when tectonic plates meet.
Spoiler alert.
Thanks, Joey. Gracias. That was interesting. We'll be right back.
Hey everyone, welcome back to WHY Action News, only on the Whynauts channel. If it happened over the last billion years, give or take, you'll hear about it right here.
Today in the news, los límites de las placas y qué pasa cuando se encuentran. Plate boundaries. When tectonic plates move around the world, they're bound to meet. And when they do, exciting things happen. Joey?
Thanks, everyone. There are three different types of plate boundaries: divergent, convergent, and transform.
Hay tres tipos de límites de las placas: divergentes, convergentes y transformadores.
A divergent boundary occurs when two tectonic plates move away from each other.
Los límites divergentes suceden cuando se alejan las placas entre ellas. We're getting reports of earthquakes and magma rising from the Earth's mantle, solidifying to create new oceanic crust.
That's right. The Mid-Atlantic Ridge is a great example of a divergent plate boundary. The new oceanic crust formed here creates the Atlantic Ocean basin, and it's still growing.
Next up, convergent boundaries. These occur when two tectonic plates move towards each other.
Los límites convergentes pasan de tres formas. Convergent boundaries can occur in three different ways: between two continental plates, between two oceanic plates, and between one of each, one oceanic and one continental. entre dos placas continentales, dos oceánicas y una continental y una oceánica.
That's right. When an oceanic plate meets a continental plate, look out! Cuidado! The oceanic plate is subducted below the continental plate.
And for our viewers at home, what does it mean to be subducted?
I'll take that one. Subduction is when the edge of a more dense oceanic plate moves downward into the mantle beneath another less dense plate. La placa oceánica, que es más densa, se desliza hacia el manto debajo de la placa menos densa, en este caso, debajo de la continental.
Looks like we're getting reports of underwater trenches, more earthquakes, and volcanoes.
What about when two continental plates converge?
¿Qué pasa cuando dos placas continentales convergen?
Well, you get mountains. Tienes montañas. Some of them are big. Have you heard of the Himalayas or Mount Everest?
That's big. Speaking of the Himalayas, did you know that they get taller by about half an inch every year? Cada año se hacen media pulgada más altas.
The Himalayas are growing due to the continental plates colliding. But that's not the only reason mountains can change. Let's check in with Professor Mignani. She's researching the mountains in Patagonia. So, Professor, are the mountains there really growing?
They are, and they are actually growing faster than many other places on Earth. 4 centimeters a year. So that is, geologically speaking, like as fast as a rocket. Imagine that North America is rebounding back up since the last ice age, but is doing so at 6 millimeters a year, so much slower. We think that the reason why this is happening is that the ice that used to be there since the last ice age and is now melting due to the warming of the climate is removing the load of the ice from the mountains. And the mountains are rebounding back up pretty much the same way in which removing a bowling ball from a mattress will make the mattress rebound back up. You know, the mountains rebound back up depending on the type of viscosity of the mantle underneath them. Understanding the viscosity of the mantle is important because it allows us to understand how the mantle convects. And understanding how the mantle convects is important because mantle convection drives the movement of the plate at the top. By studying how fast the ice is being removed from the mountains, we are actually understanding how fast the ice is melting. And we know that Patagonia ice fields are losing ice at about 30 gigaton a year, and that ice is flowing into the ocean, and the Patagonia ice fields are contributing to about 10% of the sea level rise.
Thank you, Professor Mignani, for this special report.
Okay, Joey, what about when two oceanic plates converge?
¿Qué pasa cuando dos placas oceánicas convergen?
Well, that can cause underwater volcanoes, some of which can eventually form volcanic island arcs, such as Japan. But two oceanic plate boundaries can cause giant trenches deep in the ocean, like the Marianas Trench.
Se pueden formar volcanes en islas submarinas, o arcos de islas, o trincheras gigantes.
The Marianas Trench includes the deepest known point on Earth, at about 36,000 feet below the surface.
Last up on today's program, transform boundaries, límites, transformadores.
Transform boundaries occur when two tectonic plates are moving sideways past each other.
Sí, pasan cuando dos placas tectónicas se mueven una al lado de la otra, como la falla de San Andrés.
That's right. The most famous transform boundary in North America is the San Andreas Fault. Earthquakes can occur near these boundaries.
I'm just now getting some footage from the Pro Museum earlier today. Apparently someone freaked out on the earthquake simulator. Alguien se puso como loco.
It's an earthquake. Okay, then I think we're good now.
And that's the news.
Okay, Whynauts, let's head back to the lobby for our Plate Tectonics pop quiz.
Okay, first question. What is the theory of plate tectonics?
¿Cuál es la teoría de las placas tectónicas? Plate tectonics is the unifying theory that explains how tectonic plates move across the surface of the Earth. Es la teoría que explica cómo se mueven las placas en la superficie de la Tierra.
Why do earthquakes happen more frequently at certain places?
¿Por qué hay más terremotos en ciertos lugares?
Because they often occur at plate boundaries.
Porque los terremotos suceden usualmente en los límites de las placas. ¿Y cuáles son los límites de las placas? What are plate boundaries?
They are where tectonic plates meet. There are 3 different types of plate boundaries. There's divergent, convergent, and transform.
Los 3 tipos de límites son divergentes, convergentes y transformadores.
Yes, we did it. Remember guys, there's so many different jobs in earth science for people like you and me, such as seismologists, geophysicists, and geologists.
Science is a great career for people who like to ask, ¿por qué? Why?
And in a way, we can be just like tectonic plates. When we come together, we can change the world.
Why not?
Okay guys, why not earthquake high five? Chocanlas! Whoa!